Let's talk about messaging. The term messaging refers to the means of communication between the various services in the system. In previous sections, we talked about the spider web, the situation where all services are communicating directly with each other, which results in a huge mess of tangled URLs that will crash and burn when a URL changes. This scenario is relevant when the services communicates via REST API. However, there are more ways for services to communicate with each other, and it's important to be aware of these ways and to be able to make an educated decision about which messaging platform to choose. Note that the messaging selection is not exclusive. We can often find systems with various messaging methods, each used for different purposes. There is nothing wrong with that, and I actually encourage you to do that. Just make sure to always use the right messaging method for the right task. Before exploring the various methods, let's first set the criteria we will examine them with, to make the comparison more useful. The first criterion is, of course, performance. We will always prefer a faster method of messaging. Next is message size. Indeed, most systems do not require large messages between services, but sometimes it is useful. Next criterion is the execution model. Some messaging platform requires a request-response model, which has its limitations, and some enable long-running processes to execute. Another important criterion is the feedback and reliability. And by feedback, I mean the ability to determine whether the messaging has failed, and if it is, the ability to perform some corrective action. Not all messaging methods report the status, and this is definitely an important consideration. Feedback is also closely related to reliability. A reliable method will ensure the message will be received even if there was a problem during the process. This is very important for mission-critical systems where the data in the message has to be received no matter what. The last criterion is the complexity of implementation. If a messaging platform requires a lot of development effort, that is something we would like to know beforehand. So, let's begin our list with the most common messaging method, REST API. REST API is a de facto standard for HTTP-based messaging method between services. With REST API, the service exposes an API that uses the HTTP protocol standard, including HTTP verbs that indicate the type of action to be made. For example, get will mean retrieve entity, and post means create new entity, and so on. Performance-wise, REST API is usually very fast. Most web servers have excellent performance when dealing with regular HTTP requests, which is exactly what REST API is, and since it enables direct connection between the services with no intermediate mechanism between them, it's one of the fastest messaging platforms out there. Regarding message size, REST API adheres to the same limitation as the HTTP protocol. GET operations are usually limited to 8 kilobytes, while POST or PUT operations are usually limited to a few dozen megabytes, although it varies between web servers and platform. The execution model of REST API is request response, which means it's great for quick, short actions, but not suitable for long processes. And what about the feedback? This is where REST API really shines. Since it's a synchronous method, the caller gets immediate feedback on the action via HTTP response code. If there is a problem with the execution, it will get a 500. If there was a problem with the message it sent, it will get 400, and of course, if everything went just fine, it will get 200. There are lots more response codes, but these are the most common. By getting immediate feedback, the caller can implement an error policy to be executed when there is a problem, such as retrieve, logging, and more. So while REST API is not a reliable method in the sense that a message will arrive even if there is a problem, the excellent feedback compensates for that. However, we still don't get a fully reliable system. The complexity of REST API is virtually non-existent. All the modern development languages have specialized libraries which will help you create REST API and implement all the technical parts such as serializing the JSON, convert it to objects, and more. For example, in .NET we have ASP.NET Web API, in Java we have Spring, in Python Flask, and so on. The bottom line is very simple. Developing REST API is extremely easy. REST API is extremely useful for traditional web-based systems with either user interface that can talk REST and JSON, and almost every client technology can do that nowadays, or other services that calls its API. If you are designing such a system, REST API should be the first place to look for messaging method. Our next messaging method is HTTP push notifications, or PubSub. Push notification basically means that a client subscribes to an event, and when this event occurs, it gets a notification from the server about it. Now, there are many tools that implement this method with various kinds of technologies. Many of them implement REST API that we discussed earlier. I want to focus this discussion on special kind of push notifications, those that enable real-time communication for web applications. This kind of push notification is implemented by libraries such as SignalR or Socket.io. These libraries use advanced web techniques, such as WebSockets, to keep an HTTP client always connected to the browser, thus enabling bidirectional real-time communication, as opposed to the more traditional request-response model, where only the client initiates the communication. This method is extremely useful in applications such as chat, where a lot of clients should be notified about events, such as user typing a message. So, how this method stacks against our criteria? Performance-wise, this method is amazing. Using these libraries, messages are sent and received blazingly fast and with huge scale. One machine can send more than 10,000 messages per second, and usually even more. Regarding message size, this method is quite limited. Although not always there is a formal limitation, usually message size will not exceed a few kilobytes in order to achieve the desired performance and scale. The execution model of HTTP push notifications is quite unique. The usual implementation is that a client method is subscribed to a server event, and when it is raised, this method is executed. The subscription is maintained usually with open WebSocket connection or some implementation of long polling. When an event is raised, a method is executed on the client. The server itself does not wait for the method to complete, but is already done when the method is executed, so there are no issues such as timeout or busy threads. The feedback and reliability are the biggest drawbacks of this method. These libraries work in a fire and forget mode, and when the message is sent to the subscribers, they have no idea whether it was received or not. This means that if, for some reason, the message was not received, whether because of network problems or a bug in the client, the server will never know about it. This makes those libraries not useful for applications that require high reliability, which is most of the server-side applications. This is the reason these libraries are used mainly for client-server applications, where reliability has a much less important role. For example, in a chat app, if a single message is not delivered, it's not a disaster. But if a request to perform some action on a service is not received, the consequences can be much worse. Now, there are methods to make HTTP push notifications more reliable, but they require a complex development which will make the whole thing a lot less attractive. Regarding complexity, it is extremely easy to implement this method. The various libraries are very easy to use, and the client method is very simple. It usually takes no more than 2 or 3 lines of code to implement the server side, and another 2 lines for the client. So where should we use this method? As we said before, it's most useful in scenarios where a lot of clients should be notified fast, and we can make a compromise on the reliability. Such an apps are chat applications or monitoring apps that get constant notification, and if one notification is lost, we can live with it. The next messaging method is queue. With the queue as a messaging platform, the flow is quite different from the previous methods we discussed. With queue, a service that wants to pass a message to another service places the message in a queue engine, such as RabbitMQ or MQSeries. The other service polls the queue periodically or gets a notification from the queue and then gets the message from the queue. The main advantage of queue is that we can be sure that message will be handled once and only once. After the service grabs the message, no other service will get this message. In addition, a queue can ensure the messages are processed in the order they were received, which is not always the case with REST API. So let's analyze this method. Regarding performance, this is one of the weakest points of the queue method. As opposed to REST API and push notification, which implement direct connection between the two services, here we have an additional stop, the queue itself, that adds some latency to the messaging process. In addition, if the services use polling to check for new messages in the queue, there is usually a timer that schedules the pollings, which adds another delay. If the queue uses message persistence, which means the message is written to the database before transmitting to improve reliability, then the performance is even worse. Regarding message size, it varies between queue engines. For example, RabbitMQ limits the message size to 2 GB, although it is highly recommended to use much smaller messages. IBM Web3MQ limits the size to 100 MB. However, the best practice is to always use smaller messages, and if the content of the message is huge, for example a video file, then store it in external data store and have the message itself hold a reference to its location. The execution model for queue, as we already discussed, is polling. The service expecting the message should periodically poll the queue and check for a new message, and when one is found, retrieve and handle it. And what about feedback and reliability? Well, here the situation is a bit more complicated. The message sender, the one that puts the message in the queue, will have no idea if the target actually got it. All it knows is whether the queue received the message and is ready to pass it on. On the other hand, the queue usually has comprehensive management and monitoring tools to make sure messages are not lost on the way to the other side, and has its means to make sure there are no problems along the way. So the feedback to the sender is not very critical, aside of the actual handoff to the queue. The bottom line is that the queue is one of the most reliable forms of messaging, and if this is your top priority at the expense of performance, you should definitely consider using it. And what about complexity? Well, this is also one of the weak points of queue. In order to use it, we should include in our architecture a queue engine and learn how to use it. We will need to dedicate time for training and setup, and complex queue engines can be quite difficult to maintain. It's much more complicated than a simple REST API. So, when should we use queues? The typical use case for queues is a system with a lot of messages flowing around, where the order and reliability is top priority and the performance are secondary to them. One common example is a system that processes a huge amount of data. The data is put to queue and waits to its turn, and then it gets processed and stored in the data store. In such a system, the performance is usually not a top priority because there is no user or service that waits on the other side for the processed data. It is stored for future use, which is not known at the moment. Such a system is a classic example of queue-based messaging, since it takes advantage of the queue's strength, order and reliability, while not affected from its main weakness, performance. The last messaging method we will discuss is file-based and database-based messaging. This cumbersome term is actually quite similar to the queue method, with one important difference. While in the queue method the message was put in a queue and the queue engine made sure the message will be processed once and only once, in this method the message is placed either as a file in a designated folder or as a record in a database. Once stored, other services periodically poll the file system of the database and look for new messages. When found, the message is retrieved, either by reading the file or by retrieving the data, and processed. I won't go through all the criteria of this method since it's quite similar to the queue's criteria, except the message size, which is not limited in this method, as you can see, but I want to highlight the main difference between this method and the queue. While with queue there is a guarantee the message will be handled once and only once, in this method there is no such guarantee. Now imagine the following scenario. In our application we have a service that constantly polls the file system for new files containing telemetry data. Since we want the system to be redundant, we have 3 instances of this service, all poll the same folder. Now assume a new file is added to the folder. Immediately, 3 services try to open it for read and process its contents. This poses 2 problems. 1. The file may be locked by the first service accessing it, and the other services will get an exception. This can actually prove itself as a good thing architecture-wise, since this way the data won't be processed more than once. And this brings us to the second problem. If the file is accessible, we have 3 services processing its content and storing the data. Now, this might be tolerable in some scenarios, but in many others, it can corrupt data. Imagine a file containing money transfer records. If the record will be processed more than once, it can spell a disaster on the account owner. Now, these problems can be solved using complex mechanisms and flags, but it's best to avoid it if possible. Whenever a polling mechanism is required, it's best to use queues. So, that concludes our discussion about messaging methods. In this table, I summarized all the aspects of the various methods we discussed to make your choice easier. Remember, always make sure you are using the right messaging method. There is nothing wrong in using more than one method in your system, just make sure to always use the right one.